What in the world is a snapshot model? To help us understand what this diagram is and how it works, let's use something very relatable. Speed. Here, we've defined speed as 5 miles per hour. We could also say 15 miles per 3 hours, because numerically, they're the exact same thing. But it's preferred to use 5 miles per hour because it has 1 in the denominator. So imagine we have a car that starts here at the left side, and then it travels left to right. With a snapshot model, we represent our car as a dot at a certain displacement in miles on the graph at different snapshots in time. We tend to want to separate each snapshot by equally spaced out time increments. Here, we see our change in distance is 10 miles, but our change in time is 2 hours. Plug it into our equation for average speed, and we simplify it to its per unit rate, 5 miles per hour. Luckily, since this is not calculus class, the rates we deal with are going to be constant, as they don't change. Thus, our average speed is just the speed in general. We can extend snapshot diagrams to examine the propagation of light. Here, each graph is a snapshot in time showing the distance that light travels overall left to right. The added element is that any given point along the wave stays put horizontally and instead simply oscillates up and down. Still, our snapshot diagram simply is demonstrating that the progress of our wave is a function of distance and time. In other words, propagation speed equals the distance covered in a cycle, i.e. wavelength, per time it takes to complete that cycle, period.